Where's Christine?
I'm right here.
There she is. So we're ready for you, Christine, if you'd introduce yourself and your presentation.
Okay, we'll just go over to the hill over there where all the wedges are. My computer is lagging a little bit, so I hope everything works. So before I start, can everybody see all the pictures? Most of them, at least.
Can you speak a little louder?
My name is Christine, and my presentation is about how birds call and sing. And this is particularly interesting to me because I major in environmental science, and I love watching birds. And a way to spot a bird or identify a bird before you see them is usually by listening to their song and their calls. So usually you hear a bird before you see a bird. So let me just give you a brief overview about how a bird makes sounds. And above our heads you see this upside down Y, this structure that looks like upside down Y, and it's called a syrinx. It's also called the voice box of a bird, as opposed to the larynx, which is the voice box for a human. And the difference between a syrinx and a larynx in humans is that you see this blue sphere, and at the bottom, near the bottom of the Y, is the actual syrinx. That is located at the bottom of the trachea of the bird, and the trachea is the long protruding tube at the top, and the syrinx is located at the very bottom of the trachea of a bird, and the other two tubes that are coming out of the syrinx at the bottom are the bronchi, which lead to the lungs of the bird. So there are two compartments of a syrinx, and each compartment is above one bronchi. So that means that a bird can sing with two or more voices because they can use one part of the syrinx to make one sound and the other part of a syrinx to make the other sound. Whereas as a human's voice box, our larynx is actually at a upper part of the trachea, which is also the windpipe, and also it doesn't sit right above the bronchi that lead to the lungs in a human. So humans can't manipulate airflow as well as a bird can. Humans actually use 2% of the airflow that goes through our voice box to make sound, whereas birds actually use close to 100%. So
Is that how they trill?
Well, I'm going to explain how they trill, how they bugle, how they make all sorts of sounds. So I'm going to tell you about the different sounds that different birds make. And usually a smaller bird makes a higher pitch sound, just as you would expect a smaller instrument to make a higher pitch sound than a bigger instrument. And also, some birds have the syrinx and some birds don't. For example, the turkey vulture does not have a syrinx. So you never hear a turkey vulture sing beautiful songs like a canary would do. And some birds have more developed syrinx, and also they have more muscles around the syrinx that are able to be manipulated to vibrate the membranes inside the syrinx. That's why some birds can sing better sounding songs and also have a bigger repertoire than other birds. And the kinds of birds who can imitate human language, for example, the parrot, those birds actually have thicker tongues, so they make the sound through their syrinx, and then they manipulate the sound through their tongues. And I think it was Albert who asked me the question about trilling. So for example, the canary, which is, I think, behind Albert, the yellow canaries, they make very high trilling sounds because they have a very developed syrinx, and they can sing up to 30 sounds per second. So in that kind of speed, it sounds like it's trilling. And the most amazing thing is that between each of those sounds, they're actually taking little breaths. So they can take up to 30 or more breaths in a single second. So when you hear a bird sing, they're not actually taking one breath to sing the whole song. They're actually taking little micro breaths between each note. And they can do this because of the muscles that are next to the syrinx that control these airflows. And like I said before, some birds have more developed syrinx than others. And also, I also mentioned that some birds have bigger repertoires than others, and many scientists and researchers and bird watchers have they think that the birds that have bigger repertoires are the species that are more aware of their environment, and therefore they innovate more and they copy sounds, and therefore they are able to develop their syrinx more. For example, the mockingbird, which is next to the left of the yellow canaries, the mockingbird imitates almost any kind of bird calls and songs it hears, and you usually can't spot a mockingbird because you can't really tell what bird it actually is unless you see it. But a mockingbird usually repeats a single call or song 3 or 4 times before it goes on to the next one. So if you hear a bird going crazy with all these different calls and sounds, you can be pretty sure that it's a mockingbird. And over here, next to the cardinal, on the left of the cardinal, we see the lyrebird, which was actually in one of the readings of the course. The bird that was imitating cameras and chainsaws in the forest. This bird has a very large repertoire, so it can imitate any sound that it hears. And the mute swan over here has a syrinx, but it doesn't have a very developed syrinx, so it doesn't actually sing songs. It just sounds like a loud grunt or sounds like a bugle.